Topic 14, Synthesis number 8. If a solution containing 26 grams of mercury nitrate is allowed to react completely with a solution containing 8.564 grams of sodium sulfate according to the equation below, A. How many grams of solid precipitate will be formed? B. How many grams of the reactant in excess will remain after the reaction? The equation reads as follows. Mercury nitrate reacts with sodium sulfate to produce sodium nitrate and mercury sulfate. For part A, the question tells you that you have 26 grams of mercury nitrate and 8.564 grams of sodium sulfate. You must find the grams of mercury sulfate. Convert grams to moles of each reactant in order to find the limiting reagent, and determine how much mercury sulfate product can be formed from 26 grams of mercury nitrate reactant and 8.564 grams of sodium sulfate reactant. First, we are going to convert the 26 grams of mercury nitrate by finding the molar mass of this compound. The way to find the molar mass is as follows. Find the atomic mass of mercury, nitrogen, and oxygen, and multiply each element by the number of atoms for that element. Proceed to add the atomic mass of each element together to determine the molecular weight of the compound. The molar mass is then equal to 324.598 grams per mole of mercury nitrate. Next, we must find the molecular mass of sodium sulfate. The way to find the molar mass is as follows. Find the atomic mass of sodium, sulfur, and oxygen, and multiply each element by the number of atoms for that element. Proceed to add the atomic mass of each element together to determine the molecular weight of the compound. The molecular mass is then equal to 142.041 grams per mole of sodium sulfate. Now that we have determined the molar mass of each reactant, we can now convert from grams to moles. The question tells us that we have 26 grams of mercury nitrate. We then divide this by the atomic mass of this reactant. We then produce 0.08 moles of mercury nitrate. In order to determine the moles of solid precipitate produced, we must then multiply the moles of mercury nitrate by the ratio of mercury nitrate to mercury sulfate. We find that 0.08 moles of mercury sulfate is able to be produced. We must then find the moles of sodium sulfate produced from 8.564 grams. To do this, we divide the grams by the atomic mass of this reactant. We then produce 0.06 moles of sodium sulfate. In order to determine the moles of solid mercury sulfate produced, we must then multiply by the number of moles of sodium sulfate by the ratio of sodium sulfate to mercury sulfate from the original equation. We find that 0.06 moles of mercury sulfate is able to be produced. Thus, this is our limiting reagent, the maximum amount of mercury sulfate that is produced. We have determined that the moles of mercury sulfate that is produced and must convert the moles back to grams by finding and using the molar mass of mercury sulfate, which is 296.65 grams per mole. We then multiply the moles by the molar mass and determine our final answer for part A as 17.8 grams of mercury sulfate formed. Part B asks you to determine the number of grams of reactant that is left over after the reaction. The chart below demonstrates a simple way to convert between grams and moles. We have determined that mercury nitrate is the excess reagent. Therefore, we only use 0.06 grams of mercury nitrate. So now we must subtract the amount we produce by the amount we actually use. Thus, 0.02 moles of mercury nitrate remains in the vessel after the reaction. We now must convert 0.02 moles to grams by multiplying by the molar mass of mercury nitrate, which is 324.598 grams. Okay. You then arrive at your final answer for part B as 6.49 grams of excess mercury nitrate. Thank you for watching.